So luckily we can go even beyond text and images. So that's slightly an intro of what this talk is about. This is me. I'm Philip. I am a DevRel engineer, a background in machine learning, did a bit of data science, a bit of research in like biomedical AI, and now I'm at Superlinked working in search and kind of accurate retrieval. So what even is Superlinked? Many of you maybe have heard of Superlinked, some haven't, some have heard of it but don't know what exactly it is. Are we a vector database? No, we're not. Are we a framework? Probably yes. And are we an embedding model? Well, we are, but not maybe in the conventional sense. But we can generate embeddings. So I guess in a way we're an embedding model that can construct your embeddings. And how do we construct these embeddings? We use this concept of mixture of encoders. So the idea is that you would use different types of encoders to generate your embedding. And this embedding would be one long vector which has different subvectors within it that can encode different aspects like temporal elements, like time, recency, user interaction data, images, text, different sorts of metadata, numbers. So it goes beyond just image and text. And this gives you the ability to actually do accurate retrieval by biasing these subvectors and being able to actually cut out the re-ranking steps, the post-filtering, the boosting, the fusion, rank fusion, and integrating stuff in different queries. So it's a very cool, powerful concept. So we do have an open source repo. You can try it out and test things, and that's all cool, nice, and well. However, users want to try different things and build different things. So basically, this is the title of my talk, and the next step, beyond just having a repo and having this concept live, is how do you put that concept out there so people get to try things out and build more with it. So that's why I'm today mentioning our integration with LlamaIndex, which would help you actually use this retrieval concept in your agents, in your RAG, in your pipelines, with LlamaIndex and also LangChain. So the idea today is how can I use mixture of encoders in my work with whatever I'm doing that's a bit of agentic or related to some more complex workflows. So that's the reason why we did this with LlamaIndex and LangChain, basically to make this concept more accessible, to let the people know, okay, this is something you can try out and it works, and we're happy for people to try things out. So this is LlamaIndex. You know about it probably. It has this structure. It has documents and nodes, like the key kind of data structure of the library. And you can also have indices and retrievers. So what we do is the retriever part. So basically, we've implemented custom retrievers for LlamaIndex. So now I'll go through the process a bit on how we've done this and kind of what are the requirements. So the key implementation points are the following. So you need a specific return format where you need to have a list of nodes with scoring. So that's how LlamaIndex works. And you have a retrieve method that you kind of need to implement yourself. It needs to accept a query bundle, which contains the string and the metadata stuff. And you can implement callback support and async stuff if you want, but that's not essential. So the main thing is that you have this base retriever in the LlamaIndex library, and you just need to inherit from this. So that's the first step in which you implement a custom retriever. And the input would be this query bundle, and the output, as I said, this list of node with score. And this is also part of an article that we did where we looked through a specific use case around search through Steam games, so you can actually try things out and have a look at like a full end-to-end example. And you need to implement the abstract method. Basically, this is the code to kind of roughly do that. And that's the key kind of driver when you want to do a custom retriever. And this is roughly how the architecture looks like. So you can see that you have the user application above that has the user query that goes into the query bundle, and then that goes into the actual superlinked retriever implementation. So we have this superlinked app, which is the query client and the query descriptor, and then that goes to the superlinked framework where kind of we do our stuff. And basically, as you can see also on the right part, you have the base retriever, the one that you have to implement, and then the text node and the node with score, because you also want to kind of have a way of ranking your results and have that thing in mind. So this is the query bundle. Then we have, as I mentioned, this integration. And as you can see, the line that's like the dotted line, it just means you kind of have to re-implement that part, and that there is this inheritance relationship. The other parts are like data flow. And that's the general idea. This is how the LlamaIndex core works. As I said, the key thing is to remember to have the right input and output, and then you can implement your stuff. And that's kind of how we approach things. And yeah, this goes back again to the user query, and it's also important when building stuff, especially in search, to have, of course, to encode the query in the same way as your data, but that goes a bit beyond of how you would implement a custom retriever. And this would be the final product. So you can find this in LlamaHub. You can do a pip install. So this whole process, the way you contribute to LlamaIndex is that it generates a PyPy package that you can just install, so feel free to do this. There are some tutorials on this, but we're building more stuff around this. And we would be happy to see people to try this out, test it, build some things with it, and then as this grows, we will build more stuff, more functions, more kind of ideas on how to actually integrate a mixture of encoders with all the other things in the ecosystem. So this is kind of the basic overview, but what else can you do? That might be a question. So I think this is like where I speak more directly to you, where I tell you, okay, this is the basic implementation, but this is where I'd want you to build stuff and maybe expand this idea. So one example is you can do agentic workflows in LlamaIndex. So that's kind of their new way of doing things. So have like a multi-turn conversation and have like some form of persistent state management. Because initially you wouldn't have that. So you want, if you want a more complex agentic workflow or something of that sort, you need that multi-step nature, but also the ability to have persistent state. And you can use the custom retriever that we've built in workflows like this. So yeah, these are some examples of how you might do that, like some toy demo examples. Obviously, in a specific use case, this would be much more complex and slightly different. But it's a cool concept to have in mind because LlamaIndex provides this, and it's quite an interesting use case, especially for agentic stuff. And as we know, the retrieval part is a key aspect to agents. Like eventually you would end up with the retrieval problem, whatever your workflow is, you would most likely need to have accurate retrieval. We also have an equivalent LangChain integration. So this is also a PyPy package you can install. And the difference is that here you inherit from their base retriever also, and there's the client and query, so it's slightly different. And of course, all of these use cases, so for example, the LangChain implementation uses the default in-memory index implementation where you use the in-memory index instead of a specific vector database. But then after this, you can kind of hook up your own Qdrant and build on that. And this is just how the specific implementation is done. And you need the schema and space definition down there in the bottom. That's the part about Superlinked where you define basically these custom encoders that I spoke about. So these are, we call them spaces. So if you want to encode some user interaction data, if you want to encode some temporal elements, some numbers, some images, you would use an image space, a number space, etc. And you can also supply your own custom models as encoders. So we have this functionality too. So you can say, okay, I will just supply my vectors and use them as part of this mixture of encoders architecture. So you can derive them by hand if you want, and then have a space that would kind of supply those encoders and then generate the vector. And what you can maybe find as a starting point of pre-built work or work that can inspire you to test this out and go beyond. We have these two articles that explain a bit kind of some stuff around the integration and what we've done and how we've made this work. The LlamaIndex one is around Steam games. So you can see the example test queries. I'm looking for a strategic sci-fi game. What's a good cooperative game for teamwork? Stuff like that. And of course, you can combine you can go beyond textual queries, so it doesn't have to be just text. As you can see, for example, in the LangChain example, which is around retrieving financial reports like 10K, 8K, and so on. So it uses a data set like that. You can see a lot of these examples have this weighting. So what that means is that using Superlinked's mixture of encoders, when you end up with the final vector embedding, you can bias your search results for what you're trying to actually retrieve. So that would be useful if you're trying to see, okay, which companies can I bias more towards revenue, or I care more about revenue and net income and so on. So this can be, if you're building a different use case, it can be stuff around pricing, stuff around location, stuff around how maybe people have interacted with that, or popularity. So the idea is that if you want to have something that's a bit popular but also has a good rating, you don't want to do like multiple re-rankings, multiple steps, then fusion of queries and so on, but have a way to do one step and retrieve the right context initially. So we think that's a very useful thing you can have, and we want to make that happen for your agentic workflows, for your RAG pipelines, and that's why we've extended this to LlamaIndex and LangChain. And this is the link to one of the articles, the LlamaIndex one with the Steam games. I think you'll get access to this, so you'll be able to actually click this. And we have another one, as I said, with LangChain. So this is how the architecture of that article goes. But you can find this in more details in the actual PyPy package that implements the LangChain custom retriever. And one big question is like, okay, cool, this sounds nice, but why should I even use these packages? Why should I even test out mixture of encoders? What we do have is we've done a benchmark. We've done our custom data set, which has this multimodal aspect. So basically all of the benchmarks that are out there, like MTab, Beer, and so on, they're text only. So retrievers compete on text. And what we're trying to say is that if you have metadata also, if you have images, numbers, other aspects of your data, you're kind of doing it a disadvantage to the whole process by testing it out only with a text embedding model. So we created a data set that is e-commerce based and combines these queries where you have price included, where you have more complex descriptions, more simple descriptions, And I did a talk, maybe some of you were at Haystack a few days ago, kind of diving deeper into this. But the idea is that you want to test your retrieval models in this situation where there is a realistic problem in mind. So what happened is that we got these numbers. This will be available on our landing page probably in less than 24 hours from today. So we've tested with Vertex AI and their filters, with Azure, with the bottom one is only a text-based encoder. When you need to retrieve stuff that includes metadata, the performance is low. And we've also tested kind of natural language querying and parameterizing the query in order to make them performant. So we didn't want to give a disadvantage to Azure or to Vertex and them saying, oh, you didn't use us in the right way. We just picked the highest score. But this was the case. So that's why we believe in such use cases that include different sorts of data that's beyond text and image. You could benefit of this mixture of encoders approach. And we want you to try this, test things out, and tell us how it goes. These are some useful links. So you can see the integrations there, the LlamaIndex and the LangChain one. This is a link with a few useful stuff. One of them is an article explaining this mixture of encoders concept in more detail and how you can retrieve based on all of these aspects all together without needing to re-rank, fuse queries, and so on. And we also do, on LinkedIn, we do office hours. So you can check this out on our LinkedIn page, but basically we have like a video call chat where we talk about all things around retrieval, your problems around these pipelines. Like, it doesn't necessarily have to be about Superlinked, but the whole kind of area of search and how you build your agents around search, how you generate your embeddings, what are the problems that you have. So we're happy to chat to you about this always. And also, I'm personally happy to chat to you. So feel free to add me on LinkedIn, talk to me about potential integrations, about what we've done well, what we haven't done well. So happy to listen to your comments. So feel free to connect and let me know how it's going. Maybe there's a functionality or an integration that you think you'd benefit from, and we're happy to look into this and build it. So I guess this is the announcement for lunch. So thank you for listening to my talk. Thank you for attending, and feel free. We have also a booth, and we'll have a lightning talk later because we were part of the hackathon. So stay tuned, talk to us at the booth, and thank you.